investigating learners' engagement and science learning outcomes in different designs of participatory simulated games by Lee et al. In 2021. Introduction. The purpose of this study is to compare the student engagement and the learning outcomes in a multi-team participatory simulated game or MPSG and in a single team participatory simulated game or SPSG. It is important to differentiate these two teams. In MPSG group, each team compete each other through a multi-team participatory simulated game. Whether in a SPSG group, each team compete with single-team participatory simulated game or virtual teams. So that is the difference between MPSG group and SPSG group in terms of simulated game. There are three questions this research is trying to answer. The first one, to what extent did the students who participated in the MPSG and SPSG have different levels of engagement? The second one, what patterns of interrelationships among the different subscales of engagement can be found in the MPSG and SPSG groups? Lastly, the third, to what extent did the students who participated in the MPSG and SPSG have different learning outcomes? Now let's see a brief literature review on engagement using simulation. Past studies showed that using participatory simulations promoted learning in mathematics and science. Study also showed that there are some types of engagement which are emotional engagement, social engagement, behavioral engagement, and cognitive engagement. And according to this model, a hypothetical models, social and emotional engagement affects behavioral engagement. Emotional and social engagement also affects cognitive engagement, and behavioral engagement affects cognitive engagement. Method. This research involved 105 7th grade students recruited from two middle schools in central Taiwan. These students were put into two groups, MPSG group 50 students and SPSG group 55 students. The students voluntarily participated in the games. About participatory simulated games, teams manage and operate their own fishing company. So each team was considered as a company that ran its business. And then team has an equal amount of cash and equal number of fishing boats. In other words, each team has equal resources. The fishing company which gains the most net profits will win the game. So that is the condition. Who gains the most net profit will win the game. And each participant and in each group play a different role, whether as a captain, crew members, auctioneers, or negotiators. We see in each team there were different shapes. It means each member has each role. And lastly, the team collaboratively competes against each teams. This research used both quantitative and qualitative method. For quantitative method, this research employed two surveys. The first one, the Science Game Engagement Scale, created by Wong et al. In 2016. The second survey was the Marine Ecosystem and Sustainability Test, created by Bensby, Asarf, and Orion in 2010. And for the qualitative, this research employed interview and video classroom tape. For the data analysis, the partial least square structural equation modeling, or PLS-SEM, was utilized to verify the model construct validity of the Science Game Engagement Questionnaire for both the MPSG and SPSG group students. For the video analysis, author used frequency count observation by observing the group every 2 minutes each time for 20 seconds. Results. First, comparisons of the students' engagement. This table 1 was an ANCOVA analysis using pretest of learning activity scores as covariate and post-test of engagement questionnaire scores as dependent variable. This table indicated that only behavioral engagement was a trend toward a significant difference where the value was 0.03. It means that students in MPSG group may tend to have higher level of behavioral engagement than students in SPSG group. Second, interrelationships among subscales of students' engagement in the MPSG and SPSG groups. Figure 3 shows the structural models of the engagement variables in MPSG group. In MPSG group, social engagement was a significant and positive predictors toward behavioral engagement, where FAT coefficient equals to 0.57 and adjusted R-squares equals to 0.40. Whereas behavioral engagement was significant and positive predictors explaining the variation in their cognitive engagement, where FAT coefficient equals to 0.59 and adjusted R-squares equals to 0.46. Figure 4 was the structural model of engagement variables in SPSG group. In SPSG group, emotional engagement was a positive and significant predictors explaining variation in their behavioral engagement, where FAT coefficients equals to 0.48 and adjusted R-square equals to 0.46. Whereas behavioral engagement was a positive and significant predictor explaining variation in their cognitive engagement, where coefficient path coefficient equals to 0.45 and adjusted R squares equals to 0.39. Now let's see the summary of the significant prediction of the MPSG and SPSG groups as shown in Table 2. The result shows that both groups, MPSG, SPSG, students' cognitive engagement significantly and positively predicted their behavioral engagement. On the contrary, the SPSG group students' emotional engagement had positive relationship with their behavioral engagement, but not for MPSG group. Furthermore, the MPSG group student social engagement was the significant and positive predictors of their behavioral engagement. But this was not the case for SPSG group student. The video data showed that social and collaborative status among the team members in the SPSG group seemed to decline sooner than it did in the MPSG group. In the MPSG groups, the teamwork was sustained almost until the end of the game. And this most likely explains why the MPSG and SPSG groups showed different engagement pathways. Third, group differences in students' learning outcomes. Table 3 shows the descriptive statistic of student pre-test and post-test scores on subject performance and ANCOPA summary. The results showed that statistically significant differences were found for student knowledge of dynamic relationship, where v-value equals to 0.09, indicating that the effect size was between medium and large based on Cohen's criteria. The results also showed that statistically significant differences were found for students' knowledge of causal and cyclic relationship, where v-value equals to 0.05, indicating that the effect size was between small and medium. We can conclude that students in the MPSG groups outperform those in the SPSG group in both subscales of science knowledge relevant to the game. Conclusions and suggestion. One of the most important conclusions drawn from this research is that students' willingness to interact with peers and the quality of interaction, social engagement in this case, play an important role in students' involvement and attendance in learning activities in the MPSG group. While in the SPSG group, students' personal emotions such as reaction to peers, learning tasks, and learning content were more important to their involvement in and attendance to completing the learning activities. The author realized the limitation of this study, which was small number of students as samples. Therefore, the author suggested future studies can use involve larger samples to confirm the patterns of engagement found in the current study. Additionally, the author also suggested researchers can explore the role of the other variables such as learner prior knowledge, self-regulated strategies, and epistemic emotions in students' engagement in participatory simulations.